Then keep going.
It's your turn.
Hi, Marina.
Okay, we finally get to do calculus this semester. Past few days, we've really been focused on some pre-calc material. Now we get to get into our calculus. So today, we're going to talk about derivatives and tangent lines. Tomorrow, we will talk about area, as well as Monday.
Hey, this is the day.
I messed up the board. Sorry, today is derivatives and tangents.
And so no homework tonight.
Woo! It's still book. I just messed up my objective. All right, so do you agree that a derivative is dy dx?
I would assume so.
Okay. Well, since we are now talking about polar curves, okay, much like we did with parametric, dy dx can then be broken up further into dy d theta and dx d theta.
Oh my god.
Now, in polar form, how do we write x?
R sine theta. That's all I got.
Now, what I'm going to write in red is technically the derivative for any polar graph. However, it's not something I want you to memorize. What I want you to remember is that dy dx is the same as dy d theta over dx d theta. And I want you to set up your x and y separately so that you can use your derivative rules to find them. But, in general, if r is a function of theta, then dy dx is going to be dy d theta
That doesn't look like
It's the product rule of f of theta times sine of theta.
And so we need to write this down.
Yes.
No, maybe.
You can, but I don't want you to like memorize it.
So
But it's technically true, so we want
Because you're gonna see it in your book, okay? I want you to know where it's coming from. Okay, this is the process we're gonna take every time. And then our denominator, dx d theta, well if x is r cosine theta, then we do the product rule there.
let me get my highlighter. Because what's the product? This is a highlighter moment.
I'm glad.
What was your question? The product rule? F prime times g plus f times g prime?
Okay, I see what it is.
What? I was gonna see the Jackson 5 song.
I'm having a great day today, guys.
It's the one that he's singing.
Are you ready?
Yes.
Yeah, let's go. Let's go.
Let's take you all the process.
Yeah.
Yeah. I no longer say yes.
Write the equation. We're going to do this together. We are going to write the equation to the tangent line of the polar curve r equals 5 sine theta at theta equals pi over.
Okay, so how do you know on like an AP test when they actually want you to find the literal like tangent line and when they want you to find the derivative? 'Cause I get confused sometimes on that.
They will say derivative versus write the equation of a tangent line.
So like right now we're doing like y minus y1 equals
my
slope
God.
x minus x1.
Yes. Now, to write the tangent line, what do we need?
The derivative.
We need the derivative. Yeah. So that's the first thing that we're going to need, the derivative. However, before we talk about our derivative, dy dx, we need to think about what x and y are because we are in polar. Okay? So our x coordinates are all our cosine theta. Do you agree?
Sure.
So x is the same thing as 5 sine theta cosine theta. Because that's what r is.
I would concur. Y is our sine theta, which would be 5 sine squared. Again, concur.
Yeah, how'd you get signed to it?
Because r is 5 sine theta times sine theta. I'm just going to make sine times sine squared.
Oh,
There you
yeah,
go.
okay, I get it.
You're seeing it? Okay. Excellent. So now our derivative dy d theta.
Product rule.
Chain rule.
Well, hey, what's the chain rule?
Derivative of the outside, keep the inside the same, times the derivative of the inside. Our denominator is dx d theta, so we need to take the derivative of this with respect to theta.
Yeah.
So we're going to use the product rule. That's okay. Good with that? I want to make sure I show all my work. Okay with 5 cosine squared?
It's 5 derivative of sine is cosine. Copy is cosine squared. We are there. What you see?
Plus
Oh, now it makes sense.
5 sine theta times negative sine theta.
Which is minus 5 sine.
So we have 10 sine theta I want to make sure I show all my work. Over 5 cosine squared theta minus 5 sine squared theta. So that is our dy dx. But what we need to do is we need to figure out our xy coordinate and our slope so that we can write the equation of the tangent line. But just pause for right now. Are we okay with the process for dy dx?
Yeah.
Yes.
So now, we need a point and a slope. Which one would you like to start with?
Point. Slope. Point.
Slope.
Point. Point.
Slope.
Okay, stop!
Point.
Stop!
Slope.
Boy.
Let's put it to
Point
a
and slope at the same time.
Point,
Richard,
slope,
get up there.
Point,
That's what
slope.
you are all followers.
So dy dx
Actually, I did.
evaluated at pi over 3.
Okay, I see how it is. I'm not really sure what's happening. You will reap what you
We're
sow.
plugging pi over 3 into our derivative to find our slope. Okay? Here is where your pre-calculus teacher
This is a lot
prepared
of
you
work.
so well with your unit circles.
What's a unit circle?
So what's that?
10 times radical 3 over 2 times.
What is the
1/2.
sine of pi over 3?
1/2. Just kidding, I
What's
already messed it up.
What is the cosine of pi over 3?
Wait, the sine of
No,
60
this-
is 1/2? No way.
Sine.
It's the other way around.
No, it's the other way around.
I was right for once.
It's if you,
Yeah.
property, you can put it anywhere.
Caleb, you're smarter than you think you are. You should really have more faith in
Okay. Then we have 5 times cosine squared minus 5 times sine squared.
Well, those have common denominators. Whoa.
We allowed to use calculators on the quizzes and stuff.
Oh my god, it's too many fractions.
Yeah.
I'm gonna freak out.
Yeah.
You could have factored out 5.
Oh no, a compound fraction.
Or 2, maybe.
I'm gonna throw up.
On the red.
Wait, why would there be a radical 3 over 2?
Oh my god.
What?
Well,
Draw the unit circle real quick.
Why?
No.
Shouldn't it be drawn in your brain?
yeah. Well, I'm just saying, like,
It's
if
the
it's
sign.
square root.
4,
Oh, wait.
like 15.
Oh
Negative
no,
sign.
I see what I've done.
4.
Never mind. I'm sorry.
4.
What?
Whoa.
Whoa, now that's negative 11/4, right?
Negative 11 fourths.
That's where I.
That's not
So then,
Negative 11 fourths plus.
wouldn't that be negative?
Where are you
11?
getting negative 11 fourths?
Hey, what's
It's
5
10.
minus
Never
50?
mind.
Yeah, what's
5
5
minus
minus
5
50?
is 10. Got it.
Oh,
There.
No, like, let's try that again.
Yeah.
My goodness.
Okay.
Negative
So
10.
it's just negative radical.
That's a lot of work.
And that's just the slope.
It's a good thing you guys have grit.
But we don't.
I don't think we
Didn't
do,
you
yeah.
read the From Grit to Great emails that you got freshman year?
Did anyone?
I only read the emails I get from your brother, Benjamin.
Okay.
Oh.
Now we need x and y. X is
I saw my brother in the moment just now.
Just on one.
Oh. I swear to God.
Just all replies
Yeah.
to one
Yeah.
email.
And he was about to wear my shoes, but I said no.
Your
So mom
spares?
went to go get him spared.
Finally,
It's ridiculous.
Wait, really?
Yeah. Yes.
okay. Our x coordinate would be what?
Where did this come from?
I got 5 right
Just
through. Wow. Like,
And,
And our y coordinate?
oh, this is the.
negative 2.
Oh.
No, it would be 15. Wait.
So this is the
Yeah.
underivative or
The under.
This is just the x and the y,
Not under.
This is what we started with,
Derivative.
right?
Huh?
This is the x and the
Oh,
y that
okay.
we started with. So we have y minus y equals slope times x
Oh my. This
minus
is a lot of
x.
stuff.
So random.
It's the big problem.
So I could have done like 3 different examples or just done all of this in one big example.
Goodness.
So are they not all this huge?
Good.
Sometimes I'll just ask you for the derivative.
It seems like a lot of places that go wrong.
I get partial credit,
Wow.
and you're careful. It'll be fine.
I'm careful.
Well, maybe Richard is, but I'm still concerned.
You know what? The right attitude can make a very big difference when you're doing problems. Okay, so if you're gonna go in with a crappy attitude of I'm gonna suck at this, you probably will. So don't have the attitude.
Just really.
Okay.
I should put a watermark in the unit circle.
Okay, but all of my worst tests
A
are the ones I feel
watermark
good about.
Of the unit circle.
Yeah, all the paper in the printer, and then you won't know.
If
Recognize.
Richard has it right next to him.
I know, but
Okay,
it's
this
not
is
filled
unfair.
out.
Yeah.
It's filled out collectively.
No, it's not.
Oh yeah.
I don't know which one's pi over 3.
Really?
I can't
You don't
tell.
know which one's pi over 3.
No.
You don't.
Okay.
Richard.
Next, find the horizontal and vertical tangents. Ah, this brings us back,
Oh, that
right?
sounds hard.
That's not the new
That really does sound hard.
I'll pass.
Just write it down for now.
What does this bring us back to?
Unit 2 of last year?
Of Calculus?
Mhm.
1?
Finding horizontal and vertical tangents. You did a lot of free response problems like that.
Did Greek will do this as well?
Yeah, we did the same thing. That's okay. It's been a while. It's been like a year and a half. So
It's math. We do
Okay.
a lot of math.
So let's think about this. If dy dx is dy d theta over dx d theta,
Yeah.
which one is going to help us with the horizontal tangents?
Yeah.
The
Yes.
the dy.
One of those.
Horizontal. And vertical would be the bottom.
Okay, horizontal tangents occur when our derivative is 0, so we would want the numerator to be 0. When dx d theta is 0, that's when we're going to have vertical tangents occur. Okay, now, ladies and gentlemen, r equals 1 minus cosine theta. What is that?
Alignment.
Which kind? A cardioid. Okay,
Wait a second, but 1 over 0 is.
But it's not 0.
Oh.
okay.
I'm there.
So visualize what a cardioid looks like, a cosine cardioid, right? We probably should know
Oh, it's the
where
oh, okay.
they are, right?
Vertical.
Okay.
That's my analysis.
So, which one would you like to do first, Nick?
Why? The horizontal.
Oh, I was processing here. You asked me why?
Hey, Nick, decide. Why
Okay.
though?
So our horizontal tangents are going to occur when dy d theta is 0. So let's figure out what dy d theta is. Okay. Well, if r is 1 minus cosine theta, then our y coordinates are all 1 minus cosine theta times sine. Right? Y is r sine theta.
Wait.
This is tricky.
Oh, that's the derivative? No, that's the y.
That's just the y coordinates in general.
Then we have to
Okay.
figure out where that's 0.
Well, we have to take the
Let's take the
derivative.
Of that?
Ah.
So product rule again?
Just do the thing.
So what is the derivative of 1 minus cosine?
Sine.
Sine.
Plus 1 minus cosine theta times the derivative of sine.
Cosine.
Well, this works out pretty much.
No, it doesn't.
Oh, so no.
You should probably write with y before I get the derivative. Or else you'll just get like not really confused with it. It'd be a minus two.
We're supposed to know the 0 of that.
Luckily, I gave you a worksheet to help you solve problems like this so we could practice them before we got to here.
We did.
And we had one so very similar to this one.
I still
I'm
don't know how
fact
to
check
do
that.
it.
We're gonna send it right back.
Number 3.
Number, how do you, so
2 sine squared x equals 2 plus cosine x.
Pretty similar. So do you see how we have a cosine and a cosine squared and a sine squared?
It's complete this
Okay.
way.
No, doesn't have to be that complicated. If everything was in terms of just the cosines, it'd be a lot better, right? So
Yes.
let's take sine
Oh.
squared, and we can change it to what?
1 minus cosine.
When you move it, you move the sign over. No, that's my first thought.
Oh my.
That now cos 2 cos.
I can't see what's
That doesn't work
now.
much better. It's a much faster process.
Can you just like substitute x's for cosine theta and then just do it with that kind of brain mentality and then switch it back afterwards? Okay.
What is this factor to? What? don't agree with them, right? Okay. Maybe we should change minus plus. So that we have 2 cosine minus cosine to get us the positive one. If you need to change cosine of theta to x in order to factor this, and then change it back to cosine when we're solving, that's fine. But it's just a basic trinomial that we factored. Now we're going to set it to 0. This set to 0 essentially means the cosine of theta is negative 1/2. Do you agree?
Leave it there.
So that happens at,
We could do all this again with x. Do whatever do things.
uh-huh,
That's pi over 3, right? But it's not pi over 3. It's like a no.
I'm super hungry.
I don't know.
2 pi over 3 and
4 pi over 3?
excellent.
I already ate them.
Here, this is the cosine of theta equals 1, which means theta is
0. Yeah, just do that. And 4 pi. And 6 pi.
1 rotation is fine.
Just add a
568
plus 2
pi.
pi in at the end of that. It's implied. It's implied. So is there no vertical ones? Since there's no denominator?
We
It's just r
we
equals 1
only
minus
looked
cosine.
at the numerator. Now we're going to look at the denominator. The denominator is dx d theta. So that's what we need to look at next. X is r cosine theta. So now we need to take the derivative of x in order to figure out where we have vertical. Are you okay if I make that, well, you want to multiply first and then take the derivative? Okay, if we multiply first, we have cosine minus cosine squared.
Now what?
So now we set it equal to 0. And
Oh.
what do you see? What do you see? Sine of theta is in common. And if we factor that out, we have negative 1 plus 2 cosine. So the sine is equal to 0 at 0 and pi.
So I think it is.
And the cosine is equal to 1/2.
So pi over 3. Yeah, the like on the left side. Okay, brain break.
Break. Now,
Not quite yet.
now this is great.
They are the same. If dx d theta and dy d theta are simultaneously 0, think about a cardioid. What's happening?
It's the point.
There's a corner.
Get them out of here.
So get them out. So just like with parametric, if they're simultaneously 0, we don't have a smooth curve. So if there's any overlap, they're not going to count.
Got it. Okay.
Okay? Now, I want you to give me the coordinates in which this occurs. Okay? So we need to figure out the R value for these. So let's divide and conquer. Okay, Benjamin and Chris take 2 pi over 3. Nick and Haley take 4 pi over 3. Matthew and Benjamin take pi.
We said Benjamin.
I mean, Caleb, you're gonna take pi.
Oh, I forgot about that one.
Zane and Anthony, you have pi over 3.
What was that?
Izzy and Richard, you have 5 pi over 3. Just go back to R. Just
Oh.
go back to R.
So the cosine is
I'll tell you.
Oh, it's 1 minus. Oh.
Yes.
Yes.
Let's go.
That's for the Y.
2.
Wait, I never wrote this in
Up there.
5 pi over 3 is this one.
Yep.
We know theta.
Cosine is that one.
1/2.
So 2 pi over 3.
We have 1/2.
Cosine of 2 pi over 3.
1/2 pi over 3.
And what is 1/2? So 1 is
We got negative 1/2 for the last one.
that's 1.5.
Is that right?
They got there.
Wait, that's not right.
Isn't it positive?
It's positive 1/2.
Yeah. 3 over 2.
We also got
That makes sense. Okay. Does it make sense in our horizontal cardioid that we have 2 horizontal tangents and 3 vertical tangents? In our horizontal cardioid?
Yeah, that makes sense.
Sounds to me.
That's the butt.
Oh, yeah.
Is that what it is? Okay.
One,
I'm
two, three.
there now.
Everybody gets it.
It makes sense now.
But isn't that
So if it was sine, if it was already.
So if it was a,
sine,
wait, what if it was
would
like
be
a dimple line? That mean it would have 4 vertical
like down,
lines?
we could get downwards,
it's kind of the same, right?
but now I guess
No,
The
Or,
beam is, yeah, the beam one.
Yeah.
Okay, now here we're going to talk about like the derivative of r. So like dr d theta. Dr d theta, just before you even read or write. Dr d theta. That is describing what?
the derivative of the
So think of like dy dx. We're talking about y changing over x, right? The change of y over the change of x. So dr d theta is describing change in r over the change in theta. So r is changing as our angle is changing. Are you with me?
Yes.
Okay. So if r is 0 and our derivative is not 0, then theta equals, the number that makes that happen, is the tangent at the pole to the graph.
But if r is 0, isn't it just like a
If r is 0, we're at the pole.
So we're trying to find R. But it's equal to 0.
oh, we're finding 0?
What basically, if you're at the pole, but your derivative isn't 0, then your tangent line is just theta equals this value, and it's tangent to the curve.
Okay.
It's basically saving you the step of having to find the derivative and write the tangent line equation. It's a special thing that happens. Okay? If we have a 0, that means we're at the pole, and the derivative is not 0, then your tangent line is that angle.
What are we supposed to be doing right now?
Well, I think people are writing this down.
Yeah, that is exactly
Oh, yeah.
So just making a line. You're just supposed to know that if the derivative is not 0 at 0, and you're at. If you have a 0 on the function f, and the derivative isn't 0 at 0, then it's just a line.
Then your tangent line is at that angle. Whatever theta
So the
this
derivative is
is.
that line.
Yeah.
Theta equals a. Okay.
We got it.
Yeah.
I'm sure I'll understand that in a couple of months.
We're doing.
This is really tricky. Yeah, this is.
It's really not as complicated as you're trying to make it. Okay.
Just so you know, like, that was like this, you'll understand that. I don't sound sarcastic, but everything I say sounds sarcastic, so.
That's a good question. What's the real life application?
Yeah. When are you gonna see like a rose curve?
That's not like actually though.
Circles, if you do it that way, are just rose curves.
Are fans like calculated through rose curves?
Ceiling fans?
That I don't know the answer to. I truly don't know the answer to that. However, I feel like graphic design would be a place that, and architecture would be a place that rose curves could be beneficial.
Oh, Richard.
That's Richard.
Oh yeah, architecture. Okay. If I'm looking for the zeros of this rose curve, how many of them are there?
3.
There are. There's 3 of
It's
them.
a cosine, not a sine.
Because we start here, I'm going to go through the pole 1, 2, 3 times. Okay? If I divide the 2 over, nothing's really changed. 3 theta equals, where is the cosine equal to 0?
Pi over 2. 3 pi over 2. 5 pi over 2.
So our zeros, I haven't done any calculus, we know that, right? We're just finding zeros of the curve. We are at the pole at pi over 6, pi over 2, and 5 pi over 6. So what is happening, these are 3 tangent lines. If I come over here to pi over 6,
Is the pole the order?
yep, it is a tangent line to our curve.
I'm gonna be honest. I don't like how our graphing calculator does it too, but that's a polar graph on a Cartesian coordinate plane.
Wait,
That's I know it's fine, it's just kind of sketchy.
Pi over 2
Add pole to the graph.
is a tangent line.
So it's just wherever that.
Yeah.
See, it's really not that bad now that we.
I feel like you don't really have to do math.
No.
You just look at it.
Well,
Well, yeah, wait, you
but
have
but this is putting it into like what it is that we're looking at. Like I get that you can look at it and tell where there's
So
tangent lines.
where did the pi over 6 and pi over 2 come
When I took these and divided the 3 over.
from? Oh.
Now, is it possible for your neurons to die faster than
Isn't that what SpongeBob does?
they're constantly dying.
Okay,
But does it like
so that's it for our notes. So what I would like you to do is get out a book
Absolutely.
and do the first 2 problems of your homework assignment.
What is somebody want to read out the column for us?
It's
Yeah.
page 23.
No. Wait.
Just hold it.
Books.
9.
This one.
Oh, wait, there's a 59.
Book where
What?
You go to the gym, right?
No.
What?
You go to the gym, right?
Yeah.
You take recovery days,
So
right?
59, 65, 67,
Sundays.
And since
A
brain is a
67
muscle,
example.
does it need recovery days?
Yes, yes it does. I believe we were just on our
You just asked.
recovery.